Good afternoon, geometry guys. Here we are learning about circles. This is a roundabout lesson. Please quit throwing stuff up in the air and missing it with y'all's gigantic faces because it's being left on the ground and I clean up, not y'all. Alright, so my bad. We're starting the lesson. Sorry to disturb y'all. Okay, so the way that you name a circle, this is the symbol for circle. You name it by the letter in the middle. Circle P. Alright. Diameter. Remember, diameter goes across through the center, so this would be BC with a straight line across it because it is a line segment. Alright, name a radius. Radius goes from the center to the edge, so this would be PA with this. You would think so, but you know, we did actually have people write a degree for the side length for these polygons we had this past week. Alright, two central angles. Well, central angles are angles made at the center. So one of them would be angle CPA, and the other one would be angle BPA. Okay. Now remember, taking notes and paying attention is part of the stuff that you're supposed to be doing to make sure that you are prepared for the next test. Okay. Alright. So we're all good here. Now, this word problem is like most word problems. It has too many words. Okay. We're going to, here's right here. Change percent to the decimal, multiply by 360. Calculate the central angle for the workpiece. Alright, so this part right here. So I'm going to take 20%, change it to a decimal. You just move the decimal place 2 places to the left. Some people actually divide 20 by 100, gives you the same thing. And you get 72 degrees. Alright. Now, for the sleep, well, sleep is here. Alright. So this would be 0.31 times 360. Well, that is 111.6 degrees. Now, remember, if you were to think back to this past Friday when we had a test, and think back to what you were doing during the lessons.
What folks can't think.
Well, then they're in the wrong class.
What?
I don't know. There's tons of stuff people are watching, and they wonder why they don't know what's going on the test. Did I say you? All right. So, this is what I would suggest. We're going to cover this right now. That way there's not too much going on. All right. And so, an arc is part of a circle. A semicircle is exactly 1/2 of a circle. Okay? A minor arc is smaller than half the circle. So a minor arc would be like an acute arc. Okay? Remember, acute angles are less than 90. Well, minor arcs are less than 180. All right? A major arc is greater than 180. It's larger than half a circle. It's measured in degrees like angles, and the measure is its central angle. Okay? So, All right, minor arcs are with the endpoints only. Semicircles, major arcs, they have basically 3 of the points in it. So a semicircle. Yes.
TS.
Yes. Actually, that's part of it.
TPS.
It doesn't. P is in the middle. It's circle P. So this is TRS. Now, also it has this over it. It has an arc over it. Because we're talking about
Circle.
circles. Yes. Because some of y'all need to use your imagination. Okay? Now, shade the semicircle. Alright? Now, what is the measure of any semicircle? 180 degrees. It would make sense, but when I asked that question earlier, like directly to somebody that was 5 feet from a screen, they're like, I have no idea what's going on. So, all right. So, all right. A minor arc, okay? This is an arc that is less than 180. So what would one be?
RS.
All right. TR is one. RS is another. Okay? You know. Here's TR. Here's RS. All right. I'm doing it that way because unless you're taking notes with multiple colors, you're going to have about the same thing that I have. All right. A major arc.
Greater than 180. TS.
Okay.
TSR.
TSR. Remember, it has to have more than 2 points in it. So,
No, TRS ain't right.
no, TRS is one. I had it wrong. Here's what's funny. RST. We start here. We go all the way around. All right. That is actually one. We could label more. All right, but we don't have to. And that's what it looks like. Main reason that you're shading it is so you have a visual representation. A lot of y'all are visual learners. That's why you watch certain things over and over again. Why are you staring at that person? All right. Too bad that some of y'all won't actually like watch these videos that I make. Womp, 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 womp. All right. So I'm going to pause the recording so I'm not sitting here saying all this as people write this down. Oh, by the way, as you write it down, yes, it has to have a little arc thing on it. Somebody was really mad. They're like, why does it have to have the arc thing? I'm like, I don't know. Look at all your notes right now. They're like, mine are blank. I'm like, well, that sucks us up. All right, maybe you actually sit there and pause and recorded this because I'm not going to spell those out for you. Now, you should notice there's a big difference, again, in the names of the arcs and of the major and the minor, okay? So, that's things that you need to, you know. Anyways. Yeah, I know. Good thing. No, I'm unpaused now. All right. So, I'm going to pause as y'all do this in class. I want you to find the measurement. Hey, please die quieter. I want you to find the measurement of all of these arcs. Okay, and go. All right, ready. Let's check on this. All right. Madeline, what did you get for BC?
I got 32 degrees.
How'd you get that?
Because I looked at the numbers
Because you looked at the number. That's very good. I like that description. Some of y'all are writing this down for the first time. That's amazing. All right. So, BD. Why? Yeah. Some of y'all are like, why? Why do you asking me why? All right. ABC. So here to here to here. Yes. Now, AB. Good shot, Shaq. Now, so AB would be, yep, because that would be 180 minus 32. All right. Now, we are actually missing one of these angle measures or arc measures that we kind of need, and it's kind of easy to figure out. It would be 180 minus 58, okay, would be this right here. If we were asked this, I'm just throwing that out there, which would be, yep, 122. And then if we're asked for, let's see, this one right here. All right, so yeah, 180 plus 32, this would be, hey, while you were talking, I was going over this. Remember, that's the reason you stayed instead of going to the restroom. Okay. All right. Now, critical thinking skills. Some of y'all have it. You just refuse to use it, use your powers for good. You decide to use them for powers of evil. Okay? Or annoyingness. Yeah. So, circumference, okay, is my favorite night of the round table. It's the distance around the circle. Okay, it's basically the perimeter of the circle. And the formula is C equals pi d, d pi, doesn't matter. Now, when we're calculating this, we're going to leave it in terms of pi. Okay, so it's whatever the numbers are, pi. Okay?
Yeah, ma'am, I was talking chicken puppet.
That's good impression.
Sweet.
All right, so
Where is the circumference of the bicycle wheel?
all right, so 22. So this would be 22 pi because that's the diameter. Okay, it's, hopefully it didn't like strain yourself to know that. Now, how far does the bicycle travel with one complete revolution of its wheel? Okay, it also travels 22 pi because it is somebody said 360. I'm trying to not laugh. So it is a circle, but we're asking for distance. Remember, distance, we don't measure in degrees. All right. So it says, how many revolutions will the wheel make for 100 feet? Well, you take 100, you put over 22, and you get 50 over 11.
Pa. No, kitty, it's a bad kitty.
Now,
I hate you, kitty.
Now, so this is how it is. We were dealing with perimeter with these polygons and stuff. Now we're moving on with circles. All right. So, all right. The length of an arc is a fraction of the entire circumference of the circle. Okay. So here's the formula that you need to be doing. Okay. Why are y'all laughing? Because I said formula? Okay. All right. But I want you to use this formula, and you're going to find these two problems. All right. So we're going to check to see if they did these right. Probably not. All right. So this would be 60 over 360 times, well, all right. The radius is 12. What would the diameter be? 24. It's not as funny as 25, but yes, the radius or the diameter is twice the radius. Very good. All right, so we'd multiply this by 24 pi, and we should get 4 pi. All right, now, let's think about this. If we're saying it's a fraction, we should know the circumference. This is it. I wonder how we could find the length of this other arc, okay, without having to use that formula. Chimney, chimney, cricket, cricket. Chimney, chimney, cricket, cricket. Yeah. Now, think about it. If it's a fraction of it, this whole thing is 24 pi. All right?
This little part right here.
Is 4 pi. I wonder what the rest of it could be. 199. Oh my gosh. If we were not on the first story, I would jump out the window just to end the pain. Okay. No, at this height, I would, number one, I'd get stuck in the window. Number two, I would hurt the sidewalk. All right, so it should, let's see, if the whole thing is 24, and we know this is 4, the rest of it should be 20. Okay? Oh my gosh.
You didn't even say 20.
All right. So, all right. And that's our lesson for the day. Don't forget, hit like, subscribe with the bell, use your noodle, and don't drive people crazy. Good stuff. Good things. Roll Tide.